In our last video, we combined Bomberman with Fortnite to make it a more modern game. In a lot of ways, it really worked. Bomberman is a little dusty, and the Battle Royale mechanics gave it a speed and intensity that it lacked before. There's only one problem. The AI sucked.
Oh no!
The AI was so dumb that it wasn't any fun to play with. The same was true with the old Bomberman game I used to play. I could just ignore the AI and go with multiplayer. But then I'd have to convince my friends to play Bomberman. It's probably easier to just make the AI work. The truth is that Bomberman, much less a Bomberman Battle Royale, is much more complicated than you think. My AI logic looked like this. And that was like the 5th attempt to write the AI. It's time to take a different approach. To get there, I have to learn how machine learning works in gaming. Let's start off by talking about what your options are for your game AI. If you try to look this up, you're probably going to run into a lot of noise. I know I did. Trust me, I took the time to read the book on it. I was a lot more confused then than when I started. What I found out is that there are a lot of different ways to design your AI, but there are two overarching approaches: decision making and machine learning. Decision making is what we were doing before. Think state machines, or these complicated flowcharts. You can implement decision making in a lot of different ways, but they all boil down to this. We define what the AI should do in every situation. I tried a few different flavors of decision making in Blast Arena. I started out with a simple state machine. If you, like me, ever wasted your time going to college for computer science, you'll be familiar with this kind of diagram. This is what they look like in Unity. To make a long story short, state machines weren't a good fit, so I tried to use behavior trees. Behavior trees are like fancy state machines made for gaming. Unreal has a really nice implementation of behavior trees, with the graphical view and everything. But I wasn't building in Unreal, because Unreal for mobile games is a joke. I was building in Unity. That meant that my behavior tree went from looking like this to this. The high-level logic is pretty simple. If you're in danger, escape. Otherwise, collect power-ups and place bombs. I had to write all the code to determine if the AI was in danger, tracking things like bomb explosion trails and the falling edges of the map. You can see the red areas here are the ones that the AI thinks are dangerous. I had to write the logic for finding the best place to drop a bomb as well. The AI should try and blow up other players and breakable blocks, so the spaces next to those are the best choices. I added a little bit of randomization as well, because otherwise all the bots would pick the exact same spots to go to and to drop bombs. It only kinda worked. Like I said before, this is roughly attempt number 5. And I'm not alone in struggling with this AI challenge. I mean, check out the AI from Bomberman Live. Trying to make a full decision tree for an AI in a game like Bomberman is tough. They work better for simple AI that doesn't need to act like a human. For example, let's look at the state machine for a Pac-Man Ghost. Let's use Pinky as an example. It has 3 states: chase, frightened, and dead. When Pinky is in the chase state, it will chase after the space 2 dots in front of Pac-Man. If Pac-Man grabs a power pellet, Pinky goes into its frightened state. When frightened, Pinky just runs towards the upper left corner of the screen. If Pac-Man eats Pinky while it's in its frightened state, it goes into its dead state. In the dead state, Pinky just runs back to the center and waits to respawn. And once it does, it puts it back into the chase state. Very simple logic, and it doesn't need to act human at all. In a game like Bomberman, where your AI needs to play by the same rules as the player, machine learning might be a better approach. Machine learning uses a different mindset entirely than decision making. Think about it this way. How do you learn how to play a game? You certainly don't follow someone else's guide for every single step you take. You learn the rules of the game, how to move, what actions you can take, and you learn the goals of the game. How do I win? Then you learn by your own experience the best way to play. That's the same thing we have our AI do with machine learning. Machine learning is hard, and it's not even useful for most games. What's the AI logic for a Goomba? Go to the left, then go to the right. That's it. Imagine how annoying it would be for Goombas to try and follow you around, or to dodge your attempts to jump on them. What if they ganged up on you so that you couldn't jump on one without getting punished by the rest? For NPCs that aren't meant to play like a human, machine learning is not a good choice. For a game like this, where our bots are supposed to replace replace human players, machine learning makes sense. I'd say I have a little bit of experience with large language models.
As an AI language model, I cannot...
But seriously, I've done a little bit with language generation, prompt engineering, and stuff like that. That's only one part of machine learning, though. When you try and find out what AI means or what you can do with it, you get a million different answers and workloads and models and algorithms. Most of these aren't relevant to gaming. You could probably use a large language model like GPT-4 to power a bot, but that would be very complicated and slow. It would be like if you took a blindfolded guy and you told them what was going on the screen in Bomberman. Then the blindfolded guy would have to dictate controls to another person holding a controller. Maybe that would be a fun experiment, but it's not a very straightforward approach. So, what does work for machine learning in gaming? The main approach is called reinforcement learning. Reinforcement learning is about teaching bots to make their own decisions. Let me give you an example. Your bot is a cashier. Bots make observations about the world using their senses. They then make a decision to take actions in the world based on those observations. With reinforcement learning, we're trying to get the bot to learn a policy. A policy is defined as a mapping from observations to actions. Okay, let me make that a little simpler. Think of it like a company policy. If a cashier sees too many people in line at the register, they know that the policy is to call for more cashiers. They use the policy to dictate what action to take after they make an observation. We're missing one major piece. How are these policies created? At a company, you have a bunch of people in a meeting to decide these things. If we, the programmer, make the policy decisions, congratulations, you just made a state machine. When the bot observes something, it follows the actions we've predefined. We need the bot to come up with its own policies. So, instead of telling the cashier to call for help when they have a line of 3 or more, we reward the cashier for keeping their line short. That way, the cashier can find their own solutions for when the line starts to get too long. We also offer negative rewards, aka punishments, if the cashier does something shady to shorten the line quickly, like going to the bathroom and sending everyone else to a different line. To get your agent to make its own policies, you need to set up rewards. Putting it all together, reinforcement learning in gaming looks like this. You create bots, which we'll call agents, that use sensors to observe the game world. We define what actions they can take in the world, like moving, jumping, or dropping bombs, and we give them rewards based on positive and negative actions. They then try and get the highest score, and thus find the best policies for playing the game. Which, again, basically means if I see this, I do that. Instead of having the programmer act like the annoying friend who feels the need to explain every facet of the game to it, AI can figure out the best way to play the game itself. It's really pretty similar to how people learn to play games, and it's a good fit for a game with as many moving parts as Blast Arena. Our game is built on Unity. Unity has a machine learning package. Let's look at reinforcement learning in action with these Unity examples. In the ball balancing example, the agent has a few sensors. It can sense how his head is tilted, where the ball is, and the ball's velocity. The agent has 2 actions: rotate on the x-axis and rotate on the z-axis. Since Unity is a 3D engine, rotating on the y-axis just kind of spins you around. The agent gets a small positive reward for every second it manages to keep the ball balanced, and gets a huge negative reward every time it lets the ball drop. It can then form policies to optimize keeping the ball balanced by rotating, and to minimize the ball falling off. Check out this riveting gameplay of balancing a ball. That's a very simple example, so let's look at a more complicated one. This dungeon escape example has 3 agents working in tandem. They get rewarded as a group for their actions, and so they learn to work together. A dragon is holding a key, and is trying to escape with it through the dark portal. The agents need to get the key and use it to open the door and leave. To get the key, one of the agents has to fight the dragon. By that I mean just run into it. That agent will die, and the other one can grab the key and leave. They have to kill the dragon before it escapes through the portal. Check out this slightly less riveting sliding gameplay. Each agent has a sensor that lets them see in a cone in front of them, and they have a second sensor just to tell them if they're holding the key or not. They have 7 actions. They can turn clockwise or counterclockwise, they can move in 4 directions, or they could do nothing. They only have one way to get rewarded: open the door and escape. It's like most things in life, you get literally nothing until you reach the end. Just these simple observations, actions, and rewards give the agents enough to learn how to complete their goals. Let's break down what this looks like in Blast Arena. We're going to be using reinforcement learning because I'm not insane enough to do anything else. Yet. We're going to use the Unity Machine Learning Library, and we're going to be using the PPO algorithm. Don't worry about the details on that one. We need to define the observations, the actions, and the rewards for our bomber agent. We're going to be using a grid sensor. Our game runs on a grid, so it's a pretty natural choice. A grid sensor works very similarly to the one that the Dungeon Escape game used. It just gives the AI a top-down view of the game board, like what a human player can see. It uses tags in Unity to determine what is relevant to the agent. Our bomber agents care about the floor, both types of walls, bombs, power-ups, and, of course, other players. The actions our bomber agent can take are very straightforward. It can move in 4 directions, and it can drop bombs in 4 directions. That makes 8 actions, at least for our first take. Depending on how that goes, I might change it up so the bot can move to any accessible space, but I don't know if that's going to be necessary. The rewards will be the part that change the most when I start actually testing this. For now, we'll give the agent positive rewards for moving away from the edge, dropping bombs, getting power-ups, and destroying other players. We'll give them negative rewards for getting blown up, falling off the edge, and for standing still. Standing still is both dangerous and lame. Now we know what it takes to train our bomber AI to play our Bomberman game correctly. Now what? It's time to start training. I didn't buy this 4090 for nothing. I'm sure it'll take a few hours, or days, or weeks, but we're gonna make our Bomberman AI unbeatable.